Welcome back, everybody. In this section, we're continuing our look at linear functions, but specifically with a focus on the graphs of linear functions, which of course are going to be straight lines. Some of this section is going to be review. It depends, as always, on your background, but hopefully there's also some new things in here for you as well. So let's get started by coming up with a graph of a linear function. And there's a variety of ways of graphing a linear function, one of which, the most basic way, is just by plotting points. Usually when you first learn to graph a line, your past teachers or instructors have said, okay, pick out an x value, calculate a y, pick out an x value, calculate a y. You draw the two dots and connect the dots. So we're basically going to do the same basic thing. So here we've got this function, which is f of x, which is negative 2/3 x plus 5. So we're going to evaluate our function at a couple of places. As you know, the domain for a linear function is all real numbers, so we could pick 107 and negative 5.83, and f is totally defined there. But it's easier on you probably just to pick out relatively easy to use numbers. So I like to use 0. So that will give us negative 2/3 times 0 plus 5. And that is actually going to be 5. So we know that the point 0, 5 is on the graph. And that, of course, is the y-intercept. That fact that the y-intercept is so easy to calculate, in fact, you could read it off of the formula. The fact that that is so easy to calculate is one of the reasons that we like slope-intercept form. So for another point, I need to pick out another x value that we can use. And like I said, we could use anything you want. But this one, I noticed that the slope is a fraction. It's negative 2/3. And while there's nothing wrong with fractions, it'll be a little easier on me if I can rig it so that our output value will come out to be a whole number instead of a fraction. Like if I put in 1, like f of 1, I'll have negative 2/3 plus 5, which is 4 1/3. And then you're going to have to graph 4 1/3 on here, which you're going to have to just kind of visually eyeball it. So, sorry, that was kind of redundant. Anyway, instead, it'd be better to pick off an x value that is divisible by 3. If you pick out an x value that's divisible by 3, then you're going to end up with a whole number or integer answer. So a nice number divisible by 3 would be 3. So let's just use 3. So we'll have negative 2/3 times 3 plus 5. Okay, then here the 3's cancel. We have negative 2 plus 5, and that is 3. So that's kind of interesting. So here our input will be 3 and our output will be 3. Just for fun, let's go ahead and get another one. Let me take 6 also. It only takes 2 points to determine a line. Sometimes you may want to do a third point just as a check. Help me catch any kind of possible calculation mistakes. Plus, to be honest, it was a little disconcerting that this turned out to be 3 for both the x and y coordinates. So I want one where it's not the same for you. Okay, so there's negative 2/3 times 6. That will be negative 4 plus 5, and that'll be 1. Okay, so let me start drawing some of these dots on here. Or let me actually put the points up. This one was 6, 1. Okay, so we have the point 0, 5. Okay, that's our first point. And then we'll have the point 3, 3, which is another point. And then my last point, 6, 1, it looks like it's going to be a little off the chart here, but that's okay. Okay, so then we're just kind of going to connect the dots. And then it's a nice idea to label a couple of our points. Okay, so there we've graphed a function by plotting points. Usually we can use more information about the function to help us produce the graph. We did use the y-intercept here, and often that's a good point to use. We can also use the slope to help us draw the graph. And that's what we're going to do in this example. So this function we have negative 3/4 x plus 2. So our y-intercept is going to be the point 0, 2. F of 0 is equal to 2. And then from there, we're going to use the slope to help us produce another point on the graph. So let's see how we can think about slope to help us. So remember that the slope is the change in y over the change in x. And here it's negative 3/4. So a way to interpret that is that if we increase the x value by 4, then the y value should decrease by 3. So let's see how that will look. If from our given point, if we increase the x by 4, then we'll decrease the y by 3. That will give us a second point on the graph. The increase of 4 for x corresponds to a decrease in 3 for y. Of course, as you know, there's for a negative number fraction, there's several places where we could locate the minus sign. Our negative 3/4, we could just as well have looked at it as 3 over negative 4. 3 divided by negative 4 is the same as negative 3/4. So here we could say, well, that would be the same as if we were to increase the y by 3 and decrease the x by 4. So let me go left 4, and then I'll increase the y by 3. And that'll give us another point on the graph. Obviously a different point, but it gives us a point that is on the graph. Okay, and there's our graph of our line. So basically, starting from the y-intercept, in the case here where we had a negative slope, we saw that we could go across and then down, or we could go back and then up, and that would give us 2 separate points on the graph. Okay, it's good to be able to graph lines using some method. Plotting points, any old points that you choose, often works. Using the slope and y-intercept is a pretty good method as well. All right, so the next thing to look at is a little bit more about slope and the rate of change. So for a linear function, ax plus b, or mx plus b, the slope of the graph of f and the rate of change of f are the same thing. They're equal to a. Also, if a function has a constant average rate of change, then it's a linear function. So we have a little more to say about that. So we know that a function has a linear function has a constant slope. What we want to do in this next part is see that if you have that the condition goes both ways. If you have a function that has a constant average rate of change, then it's necessarily a linear function. So let's just suppose that f is some function, any function that you want, and you happen to know that the rate of change between a point a f of a and x f of x is a constant c. So a is a particular fixed point in the domain of f, and we'll be looking at the slope between a f of a and x f of x. So let's go ahead and calculate that slope. So that's m. And that's the change in the y's. So that's f of x minus f of a divided by the change in x's. That'll be x minus a. Okay, so then we want to solve this thing for f of x so we can get a sense of what the formula for f is like. So let's multiply to clear the fraction out. Okay, and what next? What we're going to do next is add f of a to both sides. And also I'm going to flip the equality around so that the f of x will be on the left. Okay, so we've got that. And then we have only one more step essentially, and that is just to distribute to remove the parentheses. So f of x is going to be mx minus ma plus f of a. Okay, and then that basically does it, but I'm going to do one more step just to clarify things a little bit. So we'll have mx plus f of a minus ma. Okay, so the purpose of that was basically just to group things. We started out with the assumption that f was a function with a constant average rate of change. And so we did a little bit of algebra, and we've rewritten f so that it looks like m, which is a constant, times x, plus this thing is a function of x. Notice that on the right side, the part inside of the brackets, there are no x's. That means that that's a constant relative to x. So our function f of x looks like mx plus b, meaning that it's a linear function. So what we've done basically is shown that the condition goes both directions. If you have a linear function, it's going to have constant slope. And additionally, if you have a function with a constant slope or constant average rate of change, then it's guaranteed to be a linear function. Okay, so the condition goes both directions. Okay, moving on a little bit, we've seen a bit about the y-intercept. It's time to talk about the x-intercept some. The x-intercept of a function is going to be the value of x when f of x equals 0. And we can get it by finding the 0 of this equation. 0 equals mx plus b. So we're solving that. We're going to do it specifically for this function, 5x minus 7. So we want to know the value of x that will make 0 come out. So we'll set f of x equal to 0 and solve for x. Okay, so then the x-intercept is 7/5. Notice specifically that that's not the same thing as f of 0. Okay, so that's different. That will give you the y-intercept. Okay, more examples. Still continuing to focus on graphs. So we've done examples where we were finding the equation of a line given a point or in a slope or 2 points. In this one, we're given the graph, and we're going to use that to help us produce the equation of the line. So we could do it in 2 ways. We could do it using 2 points. I think I'm just going to use a point and a slope. It looks like one point we have is the y-intercept. So it looks like the point 0, 3 is on the graph. That is that f of 0 will equal 3. And then this thing looks like a linear function. And so we're going to get its slope. So if I go from here down to actually the x-intercept, it looks like you go down 3 and right 2. Right? So the y change will be -3, the x change 2. So the slope looks like it's -3/2. So then f of x will be -3/2 x plus 3. Okay, and that's the equation of our line. All right, in the next 2 examples, we want to find the slope of the line. So we'll start with the one on the left. So the formula for slope is the change in y divided by the change in x. So here, our change in y will be 6 minus 6. Our change in x will be 11 minus 2. That's 0 divided by 9, which is 0. So this looks like a constant function, a horizontal line, and it has a slope of 0. For the next one, this looks like a vertical line. So let's calculate its slope. The change in y first, change in x second. That will give us 11 divided by 0. And 11 divided by 0 is undefined. Okay, there's no slope on a vertical line. It's undefined. Notice also that this isn't the graph of a function, actually. When working on linear functions, they necessarily will have to have a they'll have to not be vertical, and they'll have to have a defined slope. All right, so a little more about horizontal and vertical lines. A horizontal line is defined by an equation that looks like f of x equal to b, where b is a constant, and it's here they're thinking b because you could use the y-intercept there. A vertical line is defined by an equation of the form x equal a. And notice here that this makes it not a function, as we said. Okay, so then I just want to write down the equation of the line for these two lines shown here. So this one is a horizontal line, and it looks like each box is worth 1. And so it looks like it's halfway between 4 and 5. So we could say y equals, it's horizontal, so it will be y equals, and it'll be 9/2, or y equals 4.5 if you like decimals. Okay, horizontal line. For this one, it's a vertical line, so it will be x equals, and then again, each box looks like it's worth -1, or worth 1. So we'll have -1, -2, -3. So that will be our equation for our vertical line. Okay, all right, so that will be the end of this video. In the next video, we'll continue working on linear functions.